Hey everyone, my name is Brittany Keith and my presentation is on static electricity. Static electricity beyond the basics. So here's an example of how static electricity works. When you rub a balloon against a surface like your hair or a sweater, it gains a negative charge. The negative charges on the balloon attracts the positive charges on the wall. Ancient discoveries of static electricity. Greek philosopher Thales of Miletus noted that amber attracts feathers and other lightweight materials when rubbed, the first historical reference to static electricity. Benjamin Franklin's kite experiment in 1752 not only demonstrated the nature of lightning, but it also laid the groundwork for understanding electrical charge. Here's a picture of amber. Amber is linked to the discovery of static electricity because when rubbed with a material like wool or fur, it gains a static electric charge, attracting small particles like dust or feathers due to the friction-induced electron transfer. Then here's a picture of Benjamin Franklin during his kite experiment. What is static electricity? And chapter 6 in our book discusses electricity. It says because the electric charge is confined to an object and is not moving, it is called an electrostatic charge. You probably call this charge static electricity. Static electricity is an accumulated electric charge at rest that is one that is not moving. When you comb your hair with a hard rubber comb, the comb becomes negatively charged because electrons are transferred from your hair to the comb, and your hair acquires positive charge. What creates static electricity? In the BPCC library, I found an article called What Creates Static Electricity, and this is what I learned. When two objects are brought into contact and then separated, electrical charges are generated at the surfaces. The buildup of this electrical potential can lead to electrostatic discharge, with consequences that can range from discomfort to disaster. Although static electricity is a familiar subject, much still remains unknown about how and why such charges form. The physics behind static electricity. If you walk across a carpet, electrons move from the rug to you. Now you have extra electrons. If you have extra electrons piled on you, they will spill off you when you touch an object like a doorknob, and you give a shock. Shocks come from gaining or losing electric charge in a hurry. And here's a picture of it. Current developments in static electricity. ESD protection. ESD stands for electrostatic discharge and refers to sudden releases of built-up static electricity. ESD protection is a process of helping to guard sensitive electronic devices and components against the potentially damaging effects of electrostatic discharge. Environmental and safety considerations. Use anti-static materials and ESD safe workstations during handling and assembling processes. Ensure ESD safe packaging, including anti-static bags and ESD foam for storage and transportation. Ground equipment and surfaces to avoid static charge buildup. Increase humidity to reduce static risk. Use ESD wrist straps to ground personnel working on sensitive assemblies and devices. And then here's my works cited page. Thank y'all.